see if this works. Elevators. In an elevator, you can only accelerate up or down. What's the only other thing that you can be doing?
Constant velocity.
If you have constant velocity, what's your acceleration?
0.
0. So what's your net force?
0.
0. So on the scale, if it's 0 velocity, 0 acceleration.
Fn equal Fg.
Let's say we have a 100 kilogram person because it's a nice round number. What would the normal force on this person be? Isaiah?
Around 1,000 newtons.
Sure. Can we go with G equals 10 for this?
1,000.
You okay with that? Let's say G equals 10 instead of 9.8. So this is 1,000 newtons.
That's it.
That's Fg, and what do we call Fg?
Force of gravity?
The weight and the force of gravity. Are those both right?
Yes, sir.
Yes.
Yes. Those are both correct.
The downward wave force.
Finley, what is weight?
Force of gravity.
Good. Force of gravity down. Arsha, what is mass?
It's your force of gravity divided by 9.8.
Okay, yeah. It's force divided by the acceleration, right? Does your mass change if you get pulled up or down or taken to another planet or?
No.
Your mass is going to stay the same. Mass is resistance to force, right? That's what it really is. So that mass is not really going to change, but if this is a scale that this person is standing on, if we pull the elevator up or drop it down, will this number change?
Yes.
Yes. Why? How can that be?
Because you're accelerating and
Doesn't a scale tell us mass?
no one tells you the wave force.
Well, actually, not even that.
Those are the force.
Yeah, scale reads normal force.
Yes, wave
Fn, right? So if this is 0 acceleration, my scale reads 100 kilograms, right? What is it really saying? No.
force.
It's really saying that my normal force, this one, the person's being pushed up by the floor, right? And that Fn would be how much?
1,000.
Yeah. Ali's rate's 1,000. Tarina, what? How does he know that?
Because it's pushing up.
Yeah, the floor is pushing up. And how would we know that those two are the same number? I mean,
You're not accelerating.
not accelerating. So if I'm not accelerating, what's my net force?
0.
0. Yeah, 0. If my net force is 0, Soren, what would you say about my two forces?
They're equally opposite.
Equal and opposite. Good. Hey, can you click the door for us? Thank you. Okay, so here's a question for you. Take 30 seconds and determine in what conditions does this exist? Does it have to be stopped?
No.
Answer that amongst yourselves.
If it's constant velocity, it's the same. No, not so.
No? What, anyway, what conditions?
Soren is worried about his test.
Thank God Dante is not here.
I hope he fails.
He would bully me.
Special.
If Dante was here, he would bully me.
No, but he's asking for that.
Then he would realize he didn't do very.
He's asking for
Of course, right. Every test he comes up with. What did you do?
I'm just trash.
Finley. Oh, Manuel, sorry.
Can I get a cup of tea?
Yeah, kettle's hot. Arsha, you got a question?
Oh, no.
No? Good. Okay, did we decide?
Yes. I got it.
I'm gonna ask Juan, what do you think? If there's zero acceleration, do we have to be stopped? No, you're right. Huram, in what other situation can we have?
If you are in a constant velocity.
Good. So for this to be true, for our normal force to equal our gravity force, and actually it would be negative for gravity force, right, because they're opposite. For this to be true, we have to have constant velocity. It can be a constant velocity of 0, which means we're stopped, or it could be constant velocity of 3 meters per second up, or it could be a constant velocity of 6 meters per second down. It doesn't matter, as long as it's constant and unchanging, then these two are the same. And that's why we use a scale to tell us our mass, because our scale on Earth will be the same as our force of gravity. It's measuring in newtons, but we just we cut the scale down so it tells us our kilograms. Yes, Madison?
If you were to take your like bathroom scale and go in an elevator,
Yes,
it started moving up, would you see your like
absolutely.
weight decrease?
Yes. Well, would it decrease?
It would increase if you're accelerating.
Take 10 seconds, turn to the person beside you. If you're standing in an elevator that's not moving, and then it starts to move up, what's going to happen to your scale? Go.
And that is all dependent on
Only
acceleration.
accelerates at first. So it actually reverts back to normal because it accelerates at first, then it goes closer. It's not
wait,
always
is it
at the
going?
time that it's accelerating.
It goes to constant.
Bro, because it's only accelerating at the beginning. Then it goes back to. How do you know that? What? How do you know that?
Yeah, like.
How do you know that?
No, according to Dante, I wrote his,
According to Alvarez's law of
not
physics.
Reddit post.
What's Alvarez's first law of physics?
How about this group, this view? So you failed one test, now you're not a merit.
I didn't say that, but I did not.
According to my
It's
mom,
the first test.
if you don't get an A, you fail.
It's my first test.
Have you read facts?
Are your plans straight one, bro?
I get a 52% and I'm happy.
My mom literally doesn't care.
Yeah, what would you do?
I told her I got a 93 and 86.
She's like, go to
It can be, but you have to be in something accelerating you downwards really fast, like a jet fighter plane or something. That will not be.
It's actually like 86.
It's like calculated the
Pause that. I'm gonna go through that
We
one.
did the podcast episode.
I think I failed.
podcasting.
I didn't.
I was interested nothing.
So if you're standing on an elevator and it's not moving and then it starts to move up.
I started at first, then it back.
Ah, so Soren's talking about acceleration. Ilya, are we accelerating in that situation? Yes. How do you know you're accelerating? Kira, because you're moving and you were not moving before, right? So we're changing from a velocity of 0 to some positive velocity. So Soren, continue your point there.
So, if you're accelerating up, you will feel your apparent weight that heavier.
Aha, yes. Your apparent weight will grow, right? So the scale will actually move up. You can see this if you jump on a scale, right? Your normal force has to increase and the needle will go. So if you're 100 kilos and you accelerate upward, we're gonna have a net force, yes? Net force up. Does that mean that our gravity force gets less?
No.
No. Our gravity is still what?
1,000
pounds.
Is this gonna change?
No.
Never.
How do we make this change?
Voted on moon.
We gotta go to the moon, right, Ali? We gotta go somewhere else. If you're on the Earth, this is gonna stay the same. So that's gonna be the same in all these situations. Your scale says 100 kilos. But if our acceleration changes, you'll actually find that your scale number will change as well. So what's going to happen to this normal force if we're accelerating up?
It'll be bigger than go up. It's gonna go up.
It's going to get bigger, right?
How would it go up? It goes small. But how is it going up? Just like getting pushed or?
It's just that.
Yeah, what's making you accelerate when you're in the elevator?
The
Cables.
Yeah. So you have your bucket, right? If I put maybe I wonder if you'll be able to see this. Where's Lucinda?
Lucinda,
Yeah, have I not introduced you to Lucinda?
the monkey?
No, the lady. We'll use an alpaca today. Or no, what is this? Some kind of gazelle or something, yeah.
Oh, I just realized there's a video.
That's the most important question of today.
So, what was the question?
That's the most important question of today.
Yes, what is this thing? I don't know what it is. So, she's in there, and if she's sitting still, her scale reads nothing. So, where does the... Manuel was asking, how does this grow? Like, how does the normal force on her grow? What do I have to do?
Pull up.
I have to pull up on this, right? When I pull up on this, she is accelerated. But is she accelerated by the string?
No.
No, Soren's right. She's not even touching the string, right?
Accelerated by the floor.
By the floor, that's right, Max, that's right. Manuel, say that again?
The normal force of the elevator.
Exactly. So when the cable on the elevator increases its tension force, if you're inside the elevator, you get accelerated up by the floor.
It's kind of the same idea as the pulley thing we were doing. Two systems have to accelerate at the same speed.
Yes, that's correct. Yeah, if the elevator accelerates up, you have to accelerate up, right? So your normal force is going to get bigger. Let's say that, should we do some numbers for this?
Please.
Okay, give me a number for acceleration.
2.
2 meters per second. So let's say plus 2 meters per second squared is my A. Okay. Now you take a second, figure out what your normal force would be.
Doesn't that mean that gravity has to be negative 1,000 meters?
Yes, we would say this is negative.
How much does he weigh?
100 kilos.
1,200.
Good.
What did you say?
You can do it. You probably can do it in your head, right? How did he get that? How do we do that?
Because the winner.
Trey, what can we find first if we have mass and acceleration? Good. So we can find our F net is going to be mass times acceleration. So that's 100 times 2. And so that's going to be 200. Upward or downward? It's got to be upward because we're accelerating upward, right? If you're real worldy, you're going to say, okay, if I have a net force of 200, it means we won by 200. The upward force won by 200. And it's playing against gravity, which is 1,000. So if I'm going to win by 200 and I'm playing against 1,000, I have to have 1,200. If you're mathy,
F net equals Fn minus Fg.
good. No. If you're real world, you would say minus. If you're mathy, you would add these two together. And then you would say F net minus Fg would be Fn. Sorry, this is kind of messy. And so my net force is 200, and I would minus. Good, but my gravity, as someone said before, I can't remember who it was, this has to be negative, right? Because it's downwards.
Negative 9.
And so that's going to give us our 1200 newtons, and that's our F and N. So this would be 1200. So would my scale read the same, less, or more? More. Because what's my scale telling me?
Your normal force.
My scale is telling me this up here, right? So if my scale, when I'm not moving, says 100 kilos, what would it say in this situation?
600?
Good. Madison, well done. Go clap for Madison. Why 120?
1,200 divided by 10.
Yeah, if normally it says 100 when my normal force is actually 1,000, then when my normal force is 1,200, my scale would actually say 120. But are you actually 120 kilograms?
Probably.
No. Tarina's shaking her head and she's right. You're actually, what's your mass actually?
100.
100 kilos. And your weight is actually 1,000 newtons. Your weight's not going to change.
If you add a 20 kilogram turkey on the way up.
If you add a turkey on the way up, then it's Thanksgiving. Everybody can relax because it's school holidays. Yeah, Isaiah?
Why is it when you're on a scale and you like bend your knees as if you're about to jump because you don't actually jump, the weight goes up?
Tell me. You tell me.
Well,
Yeah, okay, there's a little bit to do with energy there. What about force?
The force keeps getting used.
Jeff, what do you think?
Because when you put your knees on the scale,
Yeah.
what's it ground? It's just this more going up, it's pushing you up.
Okay, so it's interesting. We have one of these somewhere, and I gotta dig it out for you guys, but does anybody have a scale with the needle that flings around?
Somewhere in my house is very
I have one somewhere, I think it's across the hall. I'll get it. If you do this, if you're standing like this, and then you go like that, you just crouch, what you'll actually see is the needle is here. And when you drop, the needle will go, what's for you down? The needle will go like this, and then it'll go over, and then it'll come back to normal. If you watch carefully, that's what it will do. Because what's happening when I go from sitting still to dropping,
Lower center of mass.
I'm actually accelerating downwards, right? So my scale gets less. And then when I hit, I have to slow myself down, so I'm accelerating upwards, and then I'm sitting still and it goes back to normal. Okay, we'll talk about we'll talk more about that. We'll take this apart.
What if I crouch at like constant though?
Well, can you go from here to constant velocity instantly? So there's got to be some acceleration at the beginning, and then while I'm going down at a constant velocity, it stays the same, but then I have to slow down at the end. Okay, this is all fine. What if I accelerate down?
Negative.
Let's say my acceleration is -3 meters per second squared. And just to avoid confusion, let's call our gravity negative too. Because someone's gonna watch the video and go, why didn't you put that negative?
Well, you kind of have to.
Okay. So my scale here is actually not gonna read 100 anymore.
Your normal force is going to be 700.
No, it's 700.
What's my net force?
Negative 3,000.
Can my net force be -300?
Yeah.
Technically.
No.
Absolutely.
No. I used to talk like that with my friend Steve. Stupid Steve. No. Did you lose all your hockey cards? No. Stupid Steve. Yes, Finley.
Do you have, like, when it's going down, do you have to make the acceleration 3?
No, it can be any number. I just made that up.
No, like when, I'm talking about the negative. Do you have to keep it negative?
You do not. If you are a real world thinker, you don't have to have negatives anywhere in this. You just have to know that it's downward. If you're mathy, then yes. You have to remember that one way is negative and the other direction is positive. Okay, so my net force is negative 300 newtons. Does that mean that my gravity grows?
No.
No, same thing.
No. So what does change then? Normal force. Eddie, what happens to it?
It goes down.
It's gonna get less than it was before, right? It's this little squat force here. It's less than gravity. By how much less?
300.
300. So if you're a normal, if you're a real world person,
So they're normal.
Okay, 700.
none of us are normal because we're in a physics classroom, so
Oh,
we are not perpendicular,
no.
parallel to the universe. That's true, it could be that. If the gravity wins by 300, then this has to be 300 less, so what's it gonna be?
700.
It's gonna be 700 newtons. If you did the mathy way, you would say my F naught is 300, and you do the same exact equation, but when you subtract the gravity, you're gonna have negative 300 minus, wait, what did I do? Negative 300 minus negative 1,000, which is still gonna end up at positive 700. So you should still get the same number. This is the Fn. This is my normal force.
Mr. Anthony,
Yeah,
can you measure the tension of a solid body?
yeah.
Like, could you like measure the tension of a human?
Yeah, certain parts of the human, yes. They would be different in different parts.
I thought you said it's different.
We used to have these tension meters in university where you can, it looks like a Band-Aid, and you put it on a piece of metal, and it's got a little LED readout. And then if you put like a beam out, and it'll say like, 45 newtons or whatever, and then you stand on the end of it, and the beam doesn't look like it changes. But this readout will tell you the tension is greater. We can do that very, very precisely. That's actually how this, do you guys use these scales before?
Yeah. Electronic balance.
That's how this works. I've had to fix a couple of these for our science department. When you take them apart, inside there's a teeny little ribbon of metal. And that's what it's doing, is it, as you put something on here, the tension changes a wee little bit, which changes the resistance of the metal. Interesting. Yeah, Madison.
Could you potentially measure the tension in like a flex bicep?
Could you potentially measure the tension?
Yeah. Is that possible to do?
Yeah, I heard you went to download chicken and got spices.
Yes, it's possible. I think it would be difficult though, because your skin on the outside is different than the muscle fibers on the inside.
So you measure the tension of your skin?
Yeah, that would be pretty easy.
The spiciest level, they give you like a little.
Measure the tension of atoms as atoms.
Does force travel at the speed of light? So like if I punch the wall, how do you feel?
Oh, does force travel at the speed of light? No.
Is it like close?
I'll show you a video to explain that in a little bit.
Nothing goes faster than the speed of light.
No, I mean.
Love does.
Love?
My love for you guys.
That's on video, Soren.
Oh. Now the whole universe can know.
We all love each other.
Whole universe is watching.
Wait, stop. There's more to this. You're gonna know all this, and then you're gonna get confused when the problems come. So, this is just accelerating up, but there's a real trouble is that how do you know if the object, if in the elevator, is accelerating up? Because I'm not gonna tell you it's accelerating up, right? There's two different situations for this. What are they?
The apple.
No, don't worry about the
Oh,
apple
Going
yet.
up, down,
Moving
or
up and accelerating
Up, down,
up.
left, right.
If it's
Slowing
moving
down.
up,
Down and slowing down.
if it's moving up, getting faster,
Constant velocity and slowing down.
that's accelerating up, right?
Yeah.
Okay, but what else could be happening?
Stop.
Moving up,
Slowing down.
Once a little bit.
Moving down,
Oh.
getting slower. Think about that for a second.
Yeah, that's
If I'm moving up and something's pushing me, speeding me up, then I'm accelerating upwards, right? If I'm moving down fast, but then I slow, I'm actually accelerating upwards. Just like if I go if I'm going fast this way, and then I hit the brakes, I'm accelerating backwards even though I'm moving forwards, right? So these are the two situations for accelerating upwards. What are the two situations for accelerating down?
moving up, getting slower.
Moving down,
getting
slowing up.
faster.
So you can be moving down, getting faster,
Moving up, getting slower.
Moving down, slow.
or moving up, getting slower. That's it. That's all you got.
You just gotta memorize it.
Well, for you, yes. Jeff. Oh, if you just need to know, like, what's on the test, that's all you need to know for elevator problem. Okay. Now I can give you different pieces of this puzzle, and you can solve for the other pieces. But this concept is basically all you need. The apple thing, it's really bothering some of you, so I'm gonna do it, but if it's gonna confuse you, and you just wanna know what's on the test and you don't wanna get extra confused, just plug your ears right now.
So it's not gonna be on the test, the apple?
No.
Yes.
Oh, okay.
that's-
Maybe for bonus.
Or maybe for the question we haven't heard.
We have heard it.
Dude, sometimes after that,
I don't know.
Come on, you gotta see.
It's not there.
If I let go of the apple,
It's a pumpkin.
what is it going to do every time?
Accelerate.
Accelerate?
Down faster than gravity.
Faster than gravity?
The elevator's moving up, right?
Oh, facts. Yeah.
So the elevator's moving up, does that affect the apple?
Yeah.
Yeah.
Whoa.
No,
You're already going
It doesn't
up.
affect the
So then-
apple, but the apple will look relative to you like it's accelerating down faster.
Okay, so this is the key. Once you release the apple,
Getting different size.
it just falls.
No.
And
9.8.
No.
Negative.
Yes.
How to like it
No.
goes down.
Yeah,
If
but
you're,
what if you're-
wait.
Wait, if you're moving up, then the apple would move up
If we're
first.
standing out here, outside the elevator,
Shooting faster.
and we watch, this is just gonna accelerate downward at 9.8.
No.
Yes.
Will it actually?
Yeah.
If it's stopped, right?
Are you accelerating upwards?
Now, if you're in the elevator, it's gonna look different. Because if you're accelerating up and you let go of the apple, it's not gonna look like it goes, accelerates down 9.8. No. If you're accelerating up and you let go of the apple, it's gonna look like it falls faster than normal.
Yeah.
You get it?
It's gonna move up and then down.
If it were to stay where it was, it would
Yeah.
eventually hit the ground, right?
Yes?
Well,
So if you're not accelerating and you let go, it goes at 9.8. If you're accelerating up and you let go, It accelerates at 9.8, but it looks like it's accelerating more than 9.8 because you're accelerating upwards. If you're accelerating down, the apple's gonna accelerate at 9.8, but what's it gonna look like?
7.
It's gonna look like it's falling slower.
7.
To the point where, if you're on the elevator at the PNE and you're falling, and you happen to have a toonie on your knee, it'll just float in front of you, right?
So you're falling in the same rate of gravity?
Yeah. I don't ask how I know that.
You tried it?
I didn't say that.
You
But if you're
actually
falling
have
and the
almost
coin will be floating, why does it look like it's floating? Things don't float.
You're both moving down.
It's accelerating at the same rate you are, right? You're falling at 9.8 and it's falling at 9.8. Now, if you try that, you've got to make sure you catch it. It's gonna go in the tracks and kill everyone. But
The Tui?
yeah,
Did you
What
get
if
out?
you use a smaller coin?
I didn't do this.
It also, the floor is very crowded. You
Yeah,
can
please,
can
exactly.
really easily just go right through. something.
Right through, yeah. No, it won't do that. It'll be fine. Terminal velocity, right?
Oh.
You're okay. You're okay that way, but you don't want it to get into the things.
Oh,
Um,
like it
if you are accelerating downward, and well, did we already go through this? If you're accelerating up, it looks like it falls faster. If you're accelerating down, it looks like it falls slower.
What if the elevator falls and you drop the apple?
Yeah, then the apple will just float there.
Oh my god, I'm so happy this is one of the tests.
Because you're accelerating at the same rate as the apple. Right?
Whoa.
Yes, Max.
How long, if you're going down.
Soren,
like,
thank you for not
a
asking me
fighter
about the
jet
distortion of space-time.
faster than the terminal velocity of a penny, and you throw a penny out the window, how long does it take for this penny to slow down?
Did I tell you about my friend in grade 4 who came back from New York?
Oh my god, finally.
No, but I'm
He
saying-
showed a taxi. I remember this one.
Finally, a new story, he says.
No, bro,
I
he
tell
just
that
showed
story
a
all
taxi.
Yeah, see, it's still
Dropped
an old
it. It went
story.
through the roof of the taxi.
Well, what I'm saying is if it's going faster, like inside something that can go faster than the terminal velocity is.
A penny would reach terminal velocity within a couple meters. If you dropped it off, if you drop it from the ceiling here, or if you drop it from a skyscraper, it's the same speed.
Wow. No, it's going faster than the terminal velocity. You throw it out the window and then it slows down. It's gonna.
Yes, that's
How
correct.
long does
Roll
that
it
take?
straight down.
Well, it depends how fast you're going.
Roll it straight down.
It's like if you're driving in a car and you have a tennis ball and the sunroof is open, if you're driving 300 kilometers an hour and you throw the tennis ball out, the instant it goes out the sunroof, it's going 300, right? Yeah?
But it's
You can
not gonna
object.
fall back into the car because it's gonna slow down.
No, it's gonna look like it goes woof, right? Because it slows down so fast. But it starts off going 300.
What if you're going so fast that, say the tennis ball can't hold together, which like the second you just launch it,
Oh,
it
yeah.
evaporates?
It's like trying to throw a pie at your friend while you're driving down the street in a convertibles.
No, it's not a true story.
No.
Right? Yeah.
Madison.
The apple weighs less than the elevator and the person. So
Yes.
wouldn't it,
But
like they accelerate at the same rate, but wouldn't there be a higher force of gravity on
yes.
Wouldn't it appear to go upwards slightly?
So if I hold up a loaf of bread and a commercial airliner and I let them go in a vacuum, no air, which one hits the ground first? Same time. Is the force of gravity the same on each thing?
Yes.
No. Force of gravity is way bigger than the plane. And this should bother you. It should bother you that those two things have way different forces, but they accelerate at the same rate. It bothered me for a long time.
Is it figure it out?
Yeah. Do you know why the acceleration is the same?
No terminal velocity. No air resistance.
We're saying no air. We're taking the air out of it.
Why are we taking the air out when
Hmm?
it feel like it?
The actual answer is that it is a little bit different. But and I can tell you why if I say, okay, what if I were to hold up the moon and I let the moon go? What would happen?
Whoa. I don't know.
It would fall.
What if I held
We
up
can attract it
Jupiter?
to the sun.
What if I held up Jupiter and I let it go?
Where would it fall?
It's a gas planet. It's filled
Yeah,
with
yeah,
gas.
yeah.
It's a gas planet.
This is the interesting thing. If you hold up Jupiter,
Holding gas.
yeah, I know. If you let it go, it will accelerate toward the Earth at 9.8.
Because
But what will the Earth do? The Earth will move up towards Jupiter, even faster than 9.8. Right? So because a loaf of bread and a commercial airliner and you and a dog and a rhinoceros
the main source.
are all negligible masses compared to the Earth, we don't see the Earth get pulled up. And so that's why everything accelerates the same rate.
So if you got a mass big enough compared to the Earth, you
And
see
the
different
first law
acceleration.
applies to this.
Yeah, and actually it does. Like when when the moon circles around us, the Earth actually rotates a bit as well. Not rotate, revolves a little bit as well.
But there's something-
Wait, doesn't that have to do with the tides or something?
Well, the moon and the sun cause the tides, yes.
How does that? So the third law applies to this, right? The action.
Absolutely, yeah. The force on each thing is the same.
So that's why it's actually moving in a circle.
In an ellipse, yeah.
Yeah, I love it.
Yeah.
Well, in that first situation, when you're accelerating up in the elevator,
Yeah.
and then drop the apple, the apple looks like it's going 11.8 meters per second.
Yes. That's how it would look. I'm gonna turn this off now.